I was expecting to finish 108's lesson, teach 109, do test corrections, and go over questions on 106, 106,
That's really ambitious there.
So, I did this, I got this done, and at that point in last class, there were 3 minutes left. And so, yeah. That said, these will still be due because the keys are on the right. So, here we go. Are you ready to learn? And learn fast. Learn fast. Learn like the wind. Are you ready? All right. Did we do polar in this class?
Yeah.
Come on. Quicker. Can we get through this? Okay. In order to add in polar, what must you do? That was in Algebra 2.
Convert it to rectangular.
Convert it to rectangular. So, you could actually get the I hat component by saying the horizontal component of 3 at an angle of 2 is 3 cosine 2. And I could add that to the horizontal component of the other vector, which is 4 cosine 5. That would be the total horizontal. That would give me the vertical component. Or how would I find it? 3 sine of 2 plus 4 sine of 5. If they wanted component form, then you would be good. If they wanted rectangular form, then you'd have to then find those numbers, put it on a graph, find the r by Pythagorean theorem, find the angle by inverse tangent. Are you with me? We talked about that yesterday. So far, so good? Good. Let's talk subtracting vectors, shall we? If I gave you this is u and this is v, and I asked you to find u minus v, you could just subtract the components. What's the total I hat? Negative 2 I hat, which you could also write in this pointy vector form. They're the same components, horizontal and vertical. And a vertical component, j hat? Negative 8, or positive 8 rather, j hat. I took 3 minus negative 5. Okay, I'm subtracting the I hat of u minus the I hat of v, and that's your total. Cool? It's important that you should be able to picture this and the 2 vectors that made it. So, in terms of drawing this, we'll draw this. All right. So,
The other one's right there.
oh, thanks. Okay. Okay, cool. Now, all is right in the world. So, say I wanted to draw this vector and the 2 that made it. One way is both from the origin. If I draw 2, 3, then it's from the origin right to 3. There's vector u. If I draw v, it's right 4 down 5. This is better if I do it on a grid, but that's okay. Right 4 down 5, and that's vector v. Do you follow? Where's u minus v then on this picture? Where would I draw it in relation to these 2? Now, in a sum, we do it's the sum of those 2 is kind of in here, but instead look at connecting the 2. Okay. What would be going left to up 8? From the head of?
The origin.
No, talk to me about going from. We won't be drawing one from the origin. You're not wrong. We're going to draw one from the origin in a second. But I'm saying from the head of one of these to the other. Now, would I go from here to there, and would that be left to up 8?
No.
It must be from V to U. Okay. This vector here is left to up 8. That's U minus V. Okay? So one is to draw both starting vectors from the origin. The other is the head to tail kind of version. If I drew U first, it's right 2, up 3, here's U, and then from the head of U, I'm going to draw V, which would take me, oh, actually not V, but sorry, negative v, okay? I need to do negative v. So negative v, instead of going right 4, down 5, I'm going to go left 4, up 5. That's negative v. And then where is then the combination? The combination u minus v, where is it on the picture? Yeah, from the origin to there would be left 2 up 8. Here's u minus v. Okay? So far so good? Moving on. All right, unit vectors. Unit is a bit of a loaded word in math because we use it in 2 totally different ways. When I say, hey, don't forget your units, that means don't forget inches or feet or meters and so on. But if I say, hey, what about that unit circle? That's awesome. Then that unit means 1. The unit circle means 1, okay? So in math, unit often means 1. Well, when I say a unit vector, that means the length or the magnitude equals 1. I hat and j hat are unit vectors. They are vectors in the horizontal and vertical distance or directions of length 1. And then we stretch them with the number in front, okay? Now, you sometimes want a unit vector in the same direction. If I were to graph u, it's left 4, up 5. Now that's great, but it's most definitely not a length of 1. I think you'll agree. How long is it? Root 41, okay? So you could actually say, if I want it to be only 1 unit, this is what I want, 1 unit, then it's a factor of root 41 too big. So I could make it shorter by dividing, okay? So to make a unit vector of u, you take the normal vector components. Actually, let me write it this way, sorry. You take the normal vector, u, and divide each component by the magnitude. So in this case, the unit vector would be the same direction. I still want to go left 4 and up 5, but I want to shorten it by dividing by root 41. If I were to take those 2 components of Pythagorean theorem down, which I suppose would be a verb, then what would the length be? 1. That would be the length. Okay? Now we throw in some calculus, finally. If I wanted a vector tangent to the curve y equals x squared minus 2x plus 1, it's frequently the case that you want to, off of a normal curve, go off in a linear kind of fashion. I mean, if you imagine if you're orbiting the Earth kind of thing, and you wanted to get away from the gravitational pull of the Earth, you would have to reach escape velocity, yeah? Go faster enough to escape velocity. And once you did, you went fast enough that you would whoosh, head off in that direction. Tangent. All right. Or and sometimes, we'll talk about that some other time. All right. But a tangent to a curve is important. You follow me? So if you want a tangent to this curve, if you graph this is x minus 1 quantity squared, yeah. And that's a parabola shifted right 1. Are you cool? Now, if I wanted a vector tangent to the curve at x equals 2, then I want a vector that's tangent, not like a tangent line so much as a tangent ray. It could actually be one of 2 directions, but the one that goes up to the right is the most logical, as you'll see in a second why. Okay, but this is what I'm looking for. What's that, yeah? What do you reckon we should do first? Yeah, we want the direction, which is determined by the derivative. So if I take the derivative of x squared minus 2x plus 1 at 2, that's 2x minus 4, or 2x minus 2 rather, at 2, which is 2, okay? It helps to make it a slope, rise over run. Okay, so that derivative is like 2 over 1, yeah? The reason I want it to be a fraction is I want to break it into components. The vector of this then would be, well, what comes first, the horizontal or the vertical? Horizontal. So do I want the rise here or the run here? I want the run here, the rise here. So the vector in that direction would be 1, 2, which makes sense. That's pretty steep. It's going up 1 over 2. That seems like the correct vector. You follow? All right. Would you then try part B, which is the same graph, but I want to change it. First of all, it's at x equals 0, so it's over here. And second, it is a unit vector. I want it to be a unit vector. So I want it to be in the right direction, but only 1 unit long. Okay. So, what'd you get for a horizontal component? 1 over 3 or 5? 5. Okay. Yeah. All right. The derivative is -2, yeah? Okay. When I break that into components, remember it's horizontal first, so I need to look at the run, which is 1, and then the rise, which is -2. That's the right direction, but then the short, yes?
Does it matter where you
It doesn't. Okay, so that's a good question. It would be either this way. Actually, what I have drawn is not this one. What do I have drawn? Yeah, I have the one going right, one down 2, so I'm actually drawing this one, but you're right. The other one is -2, or sorry, -1, +2, yeah, and that's totally fine. Now, I didn't do the other version here, but what was the other version here besides up 1, up 2 over 1? You could also do down 2, left 1, so we could have had -1, -2 here, which is just weird, you know. But yeah, absolutely, Alan, can answer your question. So to shorten it up, we divide by the magnitude, which is Pythagorean theorem, square root of 5, and there's our vector. Questions? Cool. Okay, now, unit vector normal. Normal is, math people just cannot, they gotta make your life hard, okay? You'll often hear a math person use 3 different words for perpendicular. Perpendicular, normal, and orthogonal. Okay? And it's pretty cool to know often orthogonal is one of my favorite words to say, orthogonal. Orthogonal. You can just say it over. It's fun, isn't it? Orthogonal. 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 Okay. It's just one of those. Do you have favorite words to say? Orthogonal. Efficacy. Ooh, efficacy.
Oh, chutzpah.
That sounds cool. Okay. Bubble. Bubble. I can see that. Okay. Anyway, orthogonal is one of my favorite words to say, and they're all really mean at right angles. But you to be part of the math club, you really should only use them in appropriate times. When you talk about, hey, this line and this line are at a 90-degree angle, that's perpendicular. Okay. If I say, hey, this line, or find the line normal to the curve, like we did in calculus, well, that's typical normal line to a curve. But if I talk about 2 vectors that are at right angles, that's orthogonal. Orthogonal is used with vectors, okay? They all are interchangeable, and I wouldn't mark you off if you said those vectors are perpendicular, but you lost the chance to say orthogonal if you could, okay? All right, so if I asked you to find 2 vectors orthogonal to 5, 2, I'm actually making it easy on you. Because if I draw this, 1, 2, 3, 4, 5, here's vector 5, 2. Actually, let's see. Are there two vectors perpendicular to that?
No, a lot.
I don't know. You tell me. How many are there? Here's one. Here's two. Where are the others? Yeah, actually all these are perpendicular, right? 3 dimensions. Okay, but in plane space, in 2 dimensions, how many are perpendicular? 2. Okay. If this one is up 5 or right 5 up 2, then what's one that's perpendicular?
Wait, I have a question.
Yes.
So why can't I put it like at 3, like at x equals, or I equals 3 on that line and have it like be
Here?
perpendicular? Like on the curve and be
Oh, here?
like,
I know what you mean.
Can I like point at it?
You know what you mean?
Yeah, like
How come I'm
like
stupid?
why can't it be like this?
Oh, it's from the tail. Oh, I see what you're saying. You draw it from the original point. Why I don't?
Isn't it perpendicular?
Yeah, it is. Oh, that's a good question. I never even thought about that. You always go from this original point. I don't know why.
What do you mean by
Actually, I take it back. You're right. All of these. Okay, you're right. There are infinitely many. You're correct in terms of where I could be, but in terms of the actual components to that, how many are there? 2. Okay, remember vectors can be drawn all this. So if I drew all these, they're all the same vector. Yeah, remember a vector can be anywhere. It's not defined by where it's on the graph. It's defined by its horizontal vertical parts, right? Okay, so that said, let's go. That's a really good question. I never even thought about that. All right, so besides right 5 up 2, what's perpendicular? Left. I don't want to go left 5 up 2 because that would make too big of an angle. I need to match the kind of flatness with the steepness. Yeah. Hey, does that remind you of something we normally do in Algebra 1? Perpendicular is the 1 over the opposite reciprocal. Okay, perpendicular is opposite reciprocal. So when you go to do this, you are going to, when you say reciprocal, you're switching the rise and the run. So you're really going to switch the components, the horizontal and the vertical. And do I negate both of them? Just really one of them. It doesn't matter which. Okay, so let's go there. Okay, it could also be 2, -5. Which one do I have drawn here? I have left 2 up 5, so I have this one. The other one would be down here. Yeah? You tracking? Okay. Now in 3 dimensions, this is rough. I mean, if you imagine trying to find a vector perpendicular, here's one going off in 3 dimensions, here's another one going off in 3 dimensions, it could be at any angle. There's 2 vectors perpendicular to those. There's one coming up this way. There's probably one coming up this way and one coming down this way. It's hard to find. You use matrices. So in order to introduce that idea, because my whole plan was to say, here's 2 dimensions and 3 dimensions is like it. You can actually find this by this. Okay, this is called a cross product, and actually in 3 dimensions it's a cross product.
No.
Do you remember what this is?
I tried to block it.
It's a matrix. It's actually not a matrix. This is a matrix. This is the determinant of the matrix. They're a little different, okay? This is, hey, there's a matrix. There's nothing to do here. It is what it is, you know. This is find the determinant of that matrix. And this is down to the right minus up to the right, which is 2i hat minus 5j hat. Isn't that right there? Okay. Now in 3 dimensions, you have, say I gave you 2 vectors. One was 2 in x, 3 in j hat, and 5 in k hat, and the other one was 1, 4, 7. Then you would do a cross product And then the question is, do you remember how to find the determinant of a 3 by 3?
Oh, that's a K.
Yeah, that's a K.
Okay. Yeah, I do.
So what's the I component?
What's this 2, 3, 5?
2, 3, 5 is the first vector, and 1, 4, 7 is the second.
I don't like this.
We haven't even drawn three-dimensional, so that probably doesn't mean anything. Okay, it is the I have components. Some of you should remember.
Then you flip that onto the other side.
All I remember is
I'm
something.
doing it for you.
You use the iPad to like copy it onto the other side. And then you do diagrams.
Cover up the I row and column. 21 minus 20, that's I. Okay, now J hat is a negative.
Don't you want to take a row?
Cancel out. No, you want IJK. You need to get IJK. Normally you can choose. Yes, normally you can choose, but here you have to choose.
Yeah, and then you just cover it up.
So yeah, negative 14 minus 5, so that's negative 9. J hat.
I was like, where did the H
8 minus 3 is 5K hat. That vector is orthogonal to those two. Now we'll come back to 3, so don't sweat it. Okay?
So why did you do this?
Sorry, Mr. Fontaine, to waste your time. All right. So,
You said it.
if I asked you to find a unit vector, normal 2, sine, is this the last? No. Okay. Find a unit vector, normal 2, sine at pi over 6. What would I do? Okay. All right. This is where I kick you off and I got you lost in the weeds. Find the slope, okay? I want to find, do I want this vector? No, I want that vector. It's normal, perpendicular, right?
Oh, I see what's happening.
Okay? All right, so let's start by the derivative. I want cosine of pi over 6, which is root 3 over 2, yeah? Broken into components, that would be 2 root 3. Now, is that the normal vector or the tangent vector? That's the tangent vector. What's the normal vector? Negative root 3, comma 2. You switch and negate 1 for the normal.
Either one.
Either one. Okay? All right. Are you
So then,
with me on that one?
so then when you do the determinant, that's when you know which one you should engage. Is that what?
That's what makes it orthogonal.
There's like
Okay, so good point. This is a normal vector. It's not a unit normal. You're right. I did not finish. So to make it unit vector, I need to divide by the magnitude, which is
I didn't find the.
Pythagorean theorem. It's left 3 up 2. You're finding the hypotenuse. So you're finding this for the magnitude. Pythagorean theorem.
Root 7.
The magnitude is root 7, so it'd be negative root 3 over root 7, 2 over root 7. And that's normal.
No, are you supposed to use the determinant to figure out? Because like on the one up above,
Do not,
it's not this one.
this, we just, rather than do the matrix, in 2 dimensions, it's easier just to find the slope. So I just want you to see what 3 dimensions.
So for the one above, though, we found that it was the 2 common negative 5, not the negative 5.
Either one is fine. There are 2 perpendiculars.
I missed that question.
Either one is fine.
Okay, so you're not finding like which one is.
No,
That question's over.
Just one.
Okay,
Okay,
I
yes.
got that one.
I'm right there.
Why did you keep the negative?
Why did I keep the negative here? I need the negative to go in that direction. It has to go this direction. When I do the unit, I'm just shortening it up. The direction stays. If it was negative before, it stays negative. So what? Correct. Yes. Okay. All right. Sometimes, though, instead of a length 1, you want a different length. I need to counteract this force with a force of exactly 5 newtons or whatever. You want it to be 5. Well, how am I going to make a vector of some different length than I'm given? So you can start by what we know how to do. Could I make it length 1? Yeah. Could I then make it length 3? Yeah. So you just find a unit vector, then multiply by a scalar. Okay. So if I make a unit vector, then what's a unit vector in the same direction? Root 29, 5 divided by root 29, and 2 divided by root 29. Yeah?
So that one you don't negate the force?
No, they said in the same direction, so I don't believe that's right. Okay, then how do I, that's, if I did Pythagorean theorem on that, what's the magnitude of that vector? 1. That's a unit vector. That's 1 long. I want it to be 3 long. So how do I stretch it to unit to length 3? 3. I will multiply by 3, so it's 15 over root 29, 6 over root 29. Okay? You with me? Try the last one on your own. Just sum it all up. This is a good mini-step problem. Try it. I encourage you to do it. Just take it little step at a time. Don't try to do it all at once. You do not need to draw it, I don't think.
I got -4, bottom or 2. Oh, yeah. And then 3 over 5. Isn't it Pierce? Yes, he's still fine.
Oh, I ran away. So it's -7.
Okay, that's one version. The other is positive then negative.
So -7 over 5.
One of the two. You don't have to get both. Just one.
Oh, like those 3.
Okay?
Oh no, I got 7.
How we do?
Why not?
Okay. All right, you should be able to, overall then, this is a lot of tiny little problems, none of which are hard on their own, but just a lot of little skills. Go to the other lesson. Here we go. Let's see. Let's see.
Wait,
Stop this.
I'm 21 minutes.